Thank you everyone. Today I discuss about heating effect of current electricity. When a potential difference is set up at the two ends of any conductor, then the free electrons starts to move from negative end to the positive end. That means low potential to the high potential end. Due to that flow of electron, the current electricity I starts to flow from the positive end to the negative end. When these free electrons moves through the conductor, then they have to do a certain amount of work against the resistance of that conductor. This work done against the resistance develops the heat into the conductor. This phenomenon is known as the heating effect of current. That means when current flows through the conductor, then heat is produced in the conductor, and it is the heating effect of the current. And this heat is produced due to the work done by the free electrons against the resistance. Now the question is, heat is produced in the conductor, but on which factors the produced heat depends on? It depends on produced heat depends on three factors. First of all, one is the resistance, R. Number 2, current electricity, capital I, and the current, and the time, not current, time of current flow, T. On these three factors, the amount of produced heat depends on. Now the another question is, how the produced heat depends on resistance, depends on current electricity, and depends on time. To know this, you have to study the Joule's law. Joule's law says us what is the relation between the produced heat with resistance, current electricity, and time of current flow. There are three parts of the Joule's law. First part relates the produced heat with resistance. Here the produced heat H is directly proportional to the resistance. Must be here current electricity and the time are constant. Here the produced heat is directly proportional to resistance. Second law. Here the produced heat is directly proportional to the square of the current flow. Here resistance and time are constant. This is the second law. Now the third law. Third law states that produced heat H directly proportional to the time of current flow, where resistance and current electricity through the conductor are constant. These are the three laws of Joule's heating effect. Now, here the produced heat is directly proportional to resistance. Means, if the resistance increases, then produced heat also increases. And it is in same manner. That means, if the resistance increase by two times, then the produced heat also increase by 2 times. If the resistance decrease by 3 times, then the produced heat also decrease by 3 times. Now, second law, produced heat is directly proportional to the square of the current electricity. That means, if this current electricity I is increased by 3 times, then the produced heat H, it also increases, and it is increased by 3 square, that means 9 times, because it is a square. If the current decrease by 2 times, then the produced heat also decreases, and it is decreased by 2 square, that means 4 times. Now, the third law, produced heat is directly proportional to time. Time means time of current flow. If the time of current flow increases, then the produced heat also increases in the same manner. Same manner means, if the time increases by 2 times, then the produced heat also increases by 2 times. This is the Joule's law. Now, if you join these 3 laws by the joint variation rules, then what you get? Then you get H is directly proportional to R I²T. Here R, I² and T all are variable, not constant. Now you have to remove this proportion sign, then you get a equal sign and a constant K R I²T. The value of K depends on the unit of heat. Heat has 2 units. In CGS unit it is calorie, and in SI unit it is joule. Also, the value of K depends on the medium, in which medium the experiment is done. Now, if you take the medium is air and the produced heat is taken in joule, that means in SI system, that means produced heat is taken in joule, resistance is taken in ohm, current electricity is taken in ampere, and time is taken in second. Then in case of air, that means the medium is air, the value of this K is 1. If the value of K is 1, then the formula becomes H is equal to K is 1, so it will be I²Rt. When you use this formula, that means H equal to I²Rt, then must you have to take I in ampere, R in ohm, T in second, and your answer H will be in joule. Now, if you take the produced heat in calorie, if you want to take H in calorie and the medium is air, then the value of K, it will be 0.24. If the value of K is 0.24, then the formula becomes what? The formula becomes 0.24 I²Rt. If you put this formula, here I is ampere, R in resistance, R taken in ohm, and time is taken in second, and then you get the value of H, and the unit of H will be calorie, because there is the 0.24. That means if you use this formula, then you get H in calorie, but if you put H equal to only I²Rt, then you get H in joule. This is the heating effect of current. Next video I discuss about the numericals of that chapter. Thank you.